Hello there, welcome to today's class. Okay, of course you know this is zigmatech Consult Limited. Today we will take a topic in mathematics, approximation and estimation. Okay, it is my aim that by the end of this class you should be able to define what approximation and estimation is, and you should identify round up numbers and round down numbers. Okay, you should solve problems on estimation and problems on estimation. Okay, so we will quickly check out some of the things that we have here. Okay, so let's look at some definitions. Approximation in mathematics is the degree of accuracy of numbers. Okay, it is anything similar but not exactly equal to something else. So it's something similar to something but not exactly the same as something else. Okay, a number can be approximated by rounding off. To round off, when we start to look at some numbers on the board, I will explain to you. But to round off means that a number will have to disappear, okay, either disappear completely or turns to zero. Okay, a number will become insignificant so that the number before it can gain or remain the same way it is. Okay, so I say a number can be approximated by rounding off, either rounding the number up or down. So we have something like rounding up and rounding down. So you will understand that in the next slide. Okay, so I said estimation is, in the other hand, is the process of approximating or rounding off numbers in which the value is used to avoid complicated calculations. Okay, so it is simply the process of approximating or rounding off numbers. Okay, simplifying numbers to a point that it can be easily calculated. Okay, remember, the value of the estimated number is not the real value of the number, but it's just a value that is almost the same thing as the number that we just approximated. Okay, so the next thing we need to know is round up numbers. Round up numbers. I say round up numbers are numbers that are rounded off. Like I said, to round off means for a number to either disappear or become zero. So I say round up numbers are numbers that are rounded off and add 1 to the number behind them. So round up numbers are number 5, number 6, number 7, number 8, and number 9. So those numbers are called round up numbers. They disappear or become 0, but add 1 to the number just behind them. Sometimes how I used to tell some students about round up numbers is that there are numbers that when they die, they will give birth first. They will give birth to a child that will still remain in that particular set or family before they go off. Okay, so that is round up numbers. Why round down numbers are numbers that are rounded off. To round off, like I said, to either become 0 or disappear completely, and add 0, meaning they don't add anything to the number behind them or the number before them. Okay, they don't add anything to that number. The round down numbers are number 0, number 1, number 2, number 3, and number 4. So we have 5 round up numbers, and of course we have 5 round down numbers. Okay, all right. So these numbers, they disappear and they don't add anything. So like I said in the first one, the round up number, the layman explanation, I say for round down, they die, but they don't give birth to anybody. So there is nobody around to continue with their lineage. Okay, so that is for round down numbers. So let's look at the next slide. We'll look at solving problems on approximation and estimation, and we are going to look at the ExamGuide app. We'll look at all the examples we'll take from there. Okay, from the ExamGuide app. But before I go into that, let me quickly tell you what I mean by round off numbers and round down. Okay, when we get an example, I will give you an example of what I'm talking about. Okay, so from the slide, let's look at from ExamGuide app. Okay, let's look at some numbers or some questions here. All right, the first question that appeared to me here says round off. So to round off now is to approximate. So it says we should round off the number 0.01256 to 3 significant figures. Now, let me say something first before we solve that. We can approximate numbers to either significant figures, to decimal place, to tens, maybe, or to hundreds, to the nearest hundred, to the nearest tens, to the nearest 1,000, to the nearest tens of thousand. You know, we can approximate numbers to any particular value that the examiner asks you to approximate to. Okay, so for significant figure, they say we should approximate these numbers to significant figures. Okay, all right. So the number here is number 1. Round off 0.01256 to 3 significant figures. 3 significant figures. In this class, whenever we have any equation or any question that has to do with significant figures, I will always abbreviate it as significant figure. So if it is 3 significant, I'll just say 3SF, and you know what I mean, okay? I decided to put it in full because this is our first example, all right? So the question is approximate this to 3 significant figures. So the first question you ask yourself is, how many significant figure is the number given to us? Or what is a significant figure? Okay? A significant figure is simply number from 1 to 9. Number 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are significant figures. 0 is not a significant figure. Do you understand me now? But then, there are exceptions where 0 is a significant figure. A significant figure rather. When 0 is in between 2 significant figures, 0 becomes significant. For example, if we have something like 304. Remember, I said 0 is not significant, but because 0 is between 2 figures that are significant, 0 becomes significant. So this number is 3 significant figure. But if we have something like 0.0304, you see? Now, look at this now. We have 2 zeros here. These 2 zeros, because they are not in between numbers from 1 to 9, they are not significant. It means these 2 numbers here are not significant. The only significant number here is this 0. So if we are to ask how many significant figure is this number, it is 3 significant figure. Do you understand me now? If we have 0.03040, it is only 1 0 here that is significant, which is this 0. This one is not significant because it is not in between 2 significant figures. Do you understand me now? So that is the first thing you must understand about significant figures. Okay? Significant figures. All right. Having said that, we'll now look at the question we are given, 0.01256. Now, how many significant figure is this? Look at it. This 0 is not significant. This is not significant. 1, 2, 3, 4. We have 4. This is 4 significant what? Figures. So they say we should approximate or round off this 4 significant figure number to 3 significant figure number. Okay? So what that means is, to do this, look at the last digit, which is the fourth significant number. Remember, our three significant figure will stop at this point. So what it means is that we are looking for a means to make sure that 6 go out. So that if we have something like this now, this is 1, 2, 3. So this is three significant figure. But in mathematics, you don't just, go to the exam hall and they ask you, make this number 3 significant figure, and you just go and clean 6 out. And you think you have, no. So there is a rule that you must do what? Apply. So what is that rule? To make this number a significant figure, it means 6 should do what? Go. 6 should disappear or turn to 0. Whichever one you want to do it. If 6 turns to 0 and still stay here, it becomes insignificant. Do you understand? That 0 is insignificant. So for 6 to go, remember, in defining round off numbers, that is round up and round down numbers, I told you round up numbers are numbers from 5, 6, 7, 8, 9. It means 6 here, which wants to go out now, is a round up number. Remember, round up number, I told you, they will die off, they will go off, but they will give birth to 1. They will give 1. They will add 1 to the number behind them. So it means this 6 will go off, but it will come here and add +1 to 5 to give us 0.012 what? 1 plus 5 is 6. So 0.0126, that is in what? 3 significant figure. Once you do this, you are done. Very simple and easy. So if you look at the options we have there, is option number 6, 0.0126. Option number B, 0.0126. All right? So we have successfully approximated or rounded that off to 3 significant figure. All right? So this one says evaluate. Okay, we'll come back to this. Let me remember to come back to this. I just want to begin with some of these questions that are simpler for you to understand, so that I don't confuse you with that. We'll come back to that definitely. That number 2. All right? So round off 0.00 whatever correct to 2 significant figures. Okay, let's see that. Number 2, round off 0.004365 4365 to what? Correct to what? 2 significant figure. That is to what? 2s what? F. I told you that I will start using SF. So permit me to do that. All right? So this will mean 0.004365. Okay? So they are asking us to do what? 2 significant figure. 2 significant figures should stop at the level of what? Where we have 3. This is 4 significant figure, 3 significant figure, 2 significant figure, and 1 significant figure. So this is 1, 2, 3, 4. So this number originally is 4 significant figure number. Okay? So they're asking us to correct it, to approximate it, or to round it off to 2 significant figure. Okay? Now, if you look at this number we have here, 5 will go off. Okay? If you like, add 5 to 6, there is no problem. But then it always starts from the number after where the number just after where you want to approximate to. So this one goes off, it becomes 0 off. This one goes off, it becomes 0, but it adds what here? It adds +1. So this will now give us equal to 0.0044. You must put your word to now listen to me. There is something that you must put. This number is not equal to this. Okay, when you are solving, you don't put equal to in rounding off numbers. What you put is a sign of approximation. Okay, so here it means this is approximately this is the sign. Let me give you a very big sign here so that you see it correctly. So this is approximately. telling you that the number, just like I defined in approximation, telling you that this value is not exactly the same as this value, but they are approximately equal. Do you understand me? So when this one, the first one I did here, the right thing to do is to put approximately 0.01256 is approximately equal to what? 0.0126 in 3 significant figures. That's what it means. So this next one I did here now is approximately. Remember to put this. If in exam hall, if this was to be in the exam hall and I finish solving and I go, marks will be deducted from me because I use equal to. They are not equal. Okay? They are approximate. They are approximated. Okay? So approximately equal to 0.0044 SF. Okay? All right. That is that. So let's look at other things. Okay, everything has been on significant figure, Okay, so since we have done significant figure, let's leave this one. Let's see if they can ask us to correct to other things. This also to significant figure. They say find the reciprocal of, okay, let's do this. So they say find the reciprocal of 0.65 to 3 significant figure. So let's do that. Let's quickly do that. Whenever they ask you, listen to this, to find or what a reciprocal of a number is or whatever. A reciprocal of a number is just 1 over that number. Reciprocal of 2 is just 1 over 2. Reciprocal of 5 is 1 over 5. Reciprocal of a number is just 1 over that number. Do you understand me now? Okay, so reciprocal of 0.65 is 1 over 0.65. You get that? So what is 0.65? We'll convert it to fraction. To convert this number to fraction is to do what? Is to multiply it by what? 100, so that this point goes to the right. Okay? So this will mean if we take this, see what it means. 0.65 times 100. Okay? This will mean, since it's 2 0 here, this will go 1, 2. So it will be 65 all over 100. Do you understand me now? Because this decimal point has moved 2 places to the right. So this decimal point here is now here. Okay? So this means equal to, so this is equal to 1 over 65 all over 100. Do you understand me now? That's what it means. So this originally means 1 over 1 divided by 65 over 100. That is what it means. So I have told you before here, when two fractions, this is a fraction, this is also a fraction, two fractions dividing themselves, okay? Well, it means the first fraction will be there, then the second fraction will take an inverse multiplication of it, okay? So 100 becomes the numerator, 65 becomes the denominator, then we'll change this division to multiplication. So 100 goes up and 65 comes down. Do you get that now? All right, so we're having 1 times 100 is 100, 1 times 65 is 65. Okay? So we have to, they say we should correct whatever we get here to 3 significant figure. It means that this thing must be in decimal. So let's see, 5 into 65. We look for a number that is common in 100 and in 65. 5 into 65. 5 into 6 is what? 1. Remainder what? 1. So it's 1, remainder 1. Put 1 in 5, it becomes 15. 5 into 15 is, what is it called? 3. So 5 in 65 is 13. So 5 in 100 is 20. Do you get that now? So what that means is that we have 20 over 13. Okay? All right. In some exams, they will allow you to punch your calculator. Okay? Like in your NECO basic exam, they allow you to use your calculator, but I don't think it's that in the other one. So you can do this still, okay? Since you know 12 and 13 have no common factor, take 13 to divide it. 13 divided 20 will give us 1. Listen, will give us 1, remainder what? 7. Because 13 into itself is 1. If we subtract 20, if we subtract 13 from 20, it will give you 7. So that's 7. So 13 into 20 is 1, remainder 7. That 7, we add 0 to it and add point here. Do you get the point now? So how many times will we get 13 in 70? How many times will we get 13 in what? 70. So 13 in 2 places is 26. 13 in 3 places is 39. So if 13 in 3 places is 39, in 4 it will be 39 over plus 13. This will give you what? 2. Okay? 2, carry 1 put here. 4, 5, it will be 52. Okay? We go again. So 5, it will mean 52 plus another 13. 2 plus 3, 5. This plus this is 6. So it's 65. So 65 now minus 70. Do you get the point now? So what that is that 13, this 13 into 70 is 5. Because 13 divides 70 will give us 5, remainder 5. Because 13 will go like 5 times before it gets to 65. So 70 minus 65 is equal to 5. Do you get the point now? So it's what? 5. Remember what? 5. So that 5, we bring it here again and add 0 to it because 13 can go into 50. Do you get the point now? So 13 into 50 again. How many times will 13 go into 50? 13 in 2 places is 26. In 3 places is 39. Do you get the point? If we add 39, if we add another 13 here, it will be more than 50. Let's look at that now. Let's see 13. This is 2. Carry 1 here is 4 plus this 5. That is 52. So it is actually in 39 that we will stop. It means 13 will go 3 times in 50, then there will be a remainder. It means that this 3 times, remember what? 50 minus 39. 50 minus 39. So this will be 4. We'll take 1 here. Okay, this is 10. 10 minus this is 1. So this is 11. Okay, so 13 into 11, it can go. So we add 0 to 11. We keep dividing. So 13 into 110. Let's see how many times 13. Okay, this is what calculator would have just done for you. But in a situation where you are not giving calculator, it is also possible you get this thing. That is why I'm taking time to get it for you. Okay, so let's see 110 divide by 13. So how many times will we see 13 inside 100 and what? 110. So we come 13. We say 13 into 5 is what? Is 65. So 65 now means for 6 times it will be 65 plus 13. So let's see what it is. It will give us 8 and it will give us 7. So you see, so 13 in 7 places will give us 78 plus 13. You see that? So 8 plus 3, okay, gives us 11. Okay, so give us 11, carry 1, 7 plus 1, 8 plus 1 is 9, 91. You get the point? So 13 in 8 will give us 91 plus 13. So this will be what? 1 plus 3 is equals to 4. Then, what is it again? 9 plus 1 is equal to 10. So 104. Now, remember, we are going to 110. So it means that 13 into 110 will give us 8 remainder something because it will get to 104. So we subtract 104 from this. 110 minus 104. Okay? If we take this one here, put it becomes 10. 10 minus this is 6. Here is 0. 0 minus 0 is 0. 0, okay? So what that means is that 13 into 110 will be 8. Okay? Remainder 6. So this is 8 here. Remainder what? 6. That's 6. We still put, we keep dividing like that and we'll keep getting values. But you can stop at this point since they are asking you to correct it to 3 significant figures. This is 4 significant figures already. And the fourth significant figure that we have there is a round up number. So since they say we should now keep the answer in 3 significant figures, this is where, if you look at your options, you have option D as 1.538. You can just go ahead and pick that. You will fail because what they ask is correct this answer to what 3 significant figure. So 3 significant figure of this means that 8 being a round up number, we go off and add plus 1 to 3 to give us what? 1.54. Okay? 1.54 equal to, so this last one that we have approximated, that is where your approximately will now be. So to what? To 3 significant figure. Okay, so our option that is correct there is 1.54. 1.54. All right, so the correct option there is option A. So that is how to get that. All right, let's look at some other examples. They say we should convert 3684 to standard form. So let's use one stone, kill 2 birds. Let's look at standard form as it is relating to what? As it's relating to approximations. Okay, so we can keep our very large numbers in standard forms. Okay, standard form simply means expressing numbers in the power of 10. Do you understand me now? In the power of 10. It can be in the negative or in the positive power of 10. So they're asking us to convert number 4. Solution. 3684 to standard form. Remember, I told you all real numbers, have what is it? A decimal point. Some of them are invisible. Okay. If you see any number that is not a decimal number, at the end of that number there is an invisible decimal point. Meaning this number has a decimal point 0 here. This. Okay. So all numbers that are not decimal has 0.0 in them. Okay. So what they are asking us to express this in standard form is to express it in the power of 0. In the power of 10 rather. Okay. In the power of 10. So our emphasis here is to take this point, this decimal point, to the back. When we take this decimal point to the back, this decimal point will move 1, 2, 3. Now, if you look at this decimal point, how it moved, it has moved to stay here now. This has become equal to 3.684. Okay? Because this decimal point is off this place now. Now, depending on the number of times this point moved leftwards, okay? It moved leftwards, okay? It moved what? Leftward. It will mean that it will be expressed in the power of 10 in its positive form. Do you understand me? If this point is here and is moving this way, it will be expressed in negative form. Meaning, if the point moves right, this will be in negative form. If it moves to the left, it will be in positive form. Do you understand me now? So this expression in standard form is 3.684 times 10 raised to power what? 3. So it means this is also the same thing as this. So it's also an approximation. Do you understand me now? So the answer there is 3.684 times 10 raised to power 3. All right? Now this one says, find the difference between the actual and the estimated value of 55 and 55 minus 21. So let's do that thing. So they're asking us to find the difference, okay? Find the difference between the actual value of this and the estimated value of that. So let's see. The actual value of 55 and 60 and 21 actual is 55 minus 21, which will give us what? 5 minus 1 is 4. 5 minus 2 is what? 3. Okay? So this is the difference between this number in this actual form. Now, estimated. Estimated. Let's look at the estimated value. Estimated value. Estimated will mean round off this number to the nearest tens. You know, this is unit, this is 10. Unit 10. So round it off to the nearest tens. If we want to round this number to the nearest tens, it means 5 being a round up number. We go off, become 0, and add 1 to 5 to become what? 6. So 0. So it means that 55, between 55 and 60, okay? Between 55 and 60, you can, it is, because 5 being the last number there is a round up number, it can add 1 to that 6 to become 60. So it is easier to get to 60 from 55 than it is to get to 50 from 55. What this is telling us is that the journey is nearer from 55 to 60 than from 55 to 50. If you also count it, you will see that it is closer towards 60. Do you understand the point? So here, the estimated is 60. And here, the estimated, now look at this one. They said to the near, they did not ask us, but we just know that that's what we'll do. We'll do this to the nearest tens too. This is our tens here. So 1 is what? A round down number. So 1 will turn to 0 and adds nothing. 1 goes off to become 0, adds what here? Plus 0 to 2. So 0 plus 2 is still 2. So this 0, this is now 20. So 60 minus 20 is what? Is 40. Is that it? 60 minus 20 is 40. Do you get the point now? So the question is, we should find the difference between the actual and the estimated value of this and this. So if we have 40 minus 34, okay? If we have 40, so the difference is now 40 minus 34. 40, which is the estimated value, minus 34, which is the actual value. The difference between these two stuffs now will give us what? 6. Okay? Will give us 6. So the correct answer there is option A. All right. So that is what to do there. Simplify, that is number 5. Number 6. Simplify 0.02 0.02 times 0.3055 to 3 decimal places, to 3 dp, that is decimal places. Please permit me to use that, okay? So this is 0.02 times 0.3055. So 2 decimal numbers multiplying each other, okay? Like what I will always say is, what you do in decimal multiplication of decimal number is count the number of decimal points. Here, how many decimal points in the first number? This is 1, 2. So you put it down, 2 decimal points. How many decimal places here, rather? This is 1, 2, 3, 4. Decimal place means the number of figures that you find after a decimal point. Do you understand? If you have like one number or one figure after a decimal point, then that expression is one in one decimal place. If you have two figures after the decimal point, it is in two decimal place. If you have three figures, like 1, 2, 3, this is in three decimal. But if you have 1, 2, 3, 4, this is 1, 2, 3, 4, 4 decimal places. Okay. So in this kind of expression, what you do is you bring the two numbers that you are asked to find the decimal point and multiply them. Here is 1, 2, 3, 4, 4 decimal places. So this plus 4. So in total, we're having 6 decimal places. Okay, take note of this. When we finish multiplying, I'll come back here and tell you what to do with this. Okay, all right. So this means I can decide to, okay, let's keep the 0 there. So this is 0 point, okay, let's do this first one, 0.3055. Okay, or what I can do, I can remove the point. Actually, I can remove the point, just put your 0 there so that you don't get confused. Here, put 2, put 0, and put what? 0. Okay? So we have multiply. We're multiplying now. 2 times 5 is what? 10. Right? Write down what? 0, carry 1. Are you with me? Write down what? 0, carry what? 1. Okay? 2 times 5 is 10, plus 1 is 11. So we put 1, carry what again? 1. 2 times 0 is 0 plus 1. We put 1. 2 times 3 is what? What is it called again? 2 times 3 is 6. So we put 6 here. 2 times 0 is 0. Can you see that? We come to 0 here now. We are done with this. 2 times this is 0. We got that. So here, 0 times 5 is 0. 0 times 0 is 0. 0 times 0 is 0. 0 times 5 is 0, 0 times 5 is 0, 0 times 0 is 0, 0 times 3 is what? 0, and 0 times 0 is 0. Here, 0 times 5 is 0. Sorry. Let me be sure of what I'm doing there. Okay, we're done with this too. So this now, this is 0 starting from here. 0, 0. So this is 1, 2, 3, 0, and the last 0. Then for this one, we are having 0, 0, 0, 0, and what? 0. Okay? So we add all our 0 now. Are you with me? We add all the zeros we have here. So this will be what? 0, 1, 1, 6. Okay, 1, 2, 3. Okay, this is 0. This is 0. And this is what? 0. Now, remember, I said that what we have here is 6 decimal places in all. Because here is 2 decimal places, and this is 4 decimal places. 2 plus 4 is 6. So, because the number of decimal places that are multiplying for the two figures that we are using, okay? So, we are going to count from the back, okay? We are looking for where to put the decimal point. This is a decimal number, so the answer must be in decimal point. So where do we put the decimal point? We count from here backward. So 1, 2, 3, 4, 5, 6. So the decimal point is here. Do you understand me now? So this is 0.006110. But the question says what? We should simplify this into 3 decimal places. Now, if we look at what we have here, this is how many decimal places? In decimal places, what I told you about 0 being a non-significant number does not apply here. So this is actually a decimal place. This is a decimal place. So this is how many decimal places here? Count with me. 1, 2, 3, 4, 5, 6. So this is 6 decimal places. And they're asking us to estimate it or approximate it to what? 3 decimal places. So 3 decimal places will mean 1, 2, 3. Meaning all this will go off. Why this will go off is because 0 is round down, 1 is round down, 1 is round down. So they will all go off, adding nothing to 6. So we will now say approximately is equal to 0.006. This is what? 3 decimal place, 3 dp. Do you get that now? All right, so that is that for this. All right, so the answer there is C, 0.006, option C. Okay, so I think with this, I promised you something in the second question. Let's see if we can quickly do that. Since I had already promised you that. Let's see that. So they say evaluate this and put our answer in standard what? Form. So let's see that quickly. They say we should evaluate. All right, they say we should keep our answer in standard form. So solution to this, quickly just look up so that you follow me. Now, change all these numbers to fractions. Remember, fraction means change them to the power of what? 100. Okay? So it means that 0.01, it means we should take this thing to the front, this decimal number. So it's 1, 2. It means 0.01 means 1 over 100. Okay? 0.04. 0.04 is equal to 1, 2. Okay? So it means 4 over 100. Now, 0.0002 means 1, 2, 3, 4. It means 2 over 1, 4 zeros. So 1, 2, 3, 4 because it moves 4 times. The number of times it moves will tell us how many zeros you will add. So this is what all this means. So this means 0.01 times 0.04 over 0.0002 is equal to 1 over 100 times, you see, 4, this 4 over 100, 4 over 100 divided by 2 over what? 10,000. 2 over 10,000. So that is what that means. Okay? So remember what I told you. This is equal to 1 over 100 times 4 over 100. We'll do a reciprocal of this, multiplication reciprocal of this. This division changes to multiplication now, okay? So this is what? This 10,000 go up, 2 come down. 10,000 all over 2. You see that? Okay? So this, remove this. This 0, remove this 0. This one, removes this one. This one, removes this one. Are you with me? So what we are left with is what? 1 times 4 times 1, which is 4. Then here we are left with 1 times 1 times 2, which is what? 2. You see? So 4 divided by 2, the answer is 2. But if you look at your answer there, they say we should keep the answer in standard form. There is nowhere you see 2 there. Okay? Now, what is the standard form of 2 as a number? Okay? Now, if we look at C, okay, if we look at C, what it means is that C and A, if you look at A, rather, 2, there is a point here at 2, and we are not moving that point. That point is in 2 and it is already in 2. We are not making this point to come here to become 0.2. So any number in its normal state that we are not shifting anything, okay, that number is 10 raised to power 0 because we are not shifting anything. So 2 is just on its own there. So this means 2 times 10 raised to power what? 0. Do you understand me now? Because 2, we did not do any movement for whatsoever there. There is already a point 0 there, which is invisible. Do you get the point now? So this is 2 times 10 raised to power 0. And in mathematics, whatsoever is raised to power 0 is 1. So it means 10 raised to power 0 is equal to 1. 1 times 2 is also 2. So our option, the correct option there is 2 times 10 raised to power 0. So I think with these, you should have a good understanding now of how to solve questions on approximations and estimation. Thank you very much. See you next time.